Hello to my Algebra 2 classes with Mrs. Krantz. That's Zoe. There she goes. Her poop toy, poop emoji. She loves it. Algebra 2, Mrs. Krantz. Hope everybody's doing well. And we're going to continue on in Algebra 2, Chapter 8, Solving Rational Equations and Story Problems. All right. I think I'm going to post this on Monday, May 4th. May the 4th be with you. And here we go. Rational equations have x in the denominator. Okay, we're going to solve for x. All right, do I need a least common denominator? The answer will be, what do you think? Lauren, Ismet, how about you, Madison? What do you think? Do we need an LCD? Yes, we do. If there's a plus or a minus, all right? If there was no plus or minus, you could just cross multiply. You wouldn't need LCD. All right, do I need a factor to find the LCD? Yes, I do right here. I'm gonna factor out an x, and then you get x minus 5. Then I'm gonna factor out a what here? If you said 2, you're right, and you get x minus 5. Now I'm going to find the LCD of x minus 5, and 2x minus 5. All right, so you look, you need x from the first two and 2 from that last one, so 2x, and you also need x minus 5. All right. So the LCD is 2x, x minus 5. Now here's what you do when you solve. You're going to distribute the entire LCD. I'm going to distribute the entire LCD to every term on both sides. Go with my red, I think. So I'm going to write 2x, x minus 5. 2x, x minus 5. And one more time, 2x, x minus 5. All right. Then we're going to simplify this. What cancels first? X's. So I have 2 times 2, 4 is going to get distributed to x minus 5. Right? Then what cancels on the second fraction? Looks like x's and x minus 5. So I'm left with 7 times 2, 14 equals. On the other side, 2's cancel and x minus 5. So you're left with 3x. So you will either be left with what this is, which is a linear equation, or you might be left with a quadratic. Okay? This is just a linear. We're going to distribute. And then what? Well, let's combine our like terms. So we get 4x minus 6 equals 3x. I'm going to subtract 4x. So I get negative 6 equals negative x. Divide out that negative, and you get positive 6. All right, linears will have one solution. Now, is this a good solution? Meaning, is it an extraneous solution? Well, I'm going to check by listing the restrictions. Okay, what can x not be? Look at the LCD. From 2x, x cannot be 0. And from x minus 5, x cannot be 5. I did not get 0 or 5. Check. All right. Linear, one good answer. Let's try number 2. Then we'll move on to some SPs, story problems. All right. Now on this one, I do not need to factor. Okay? I do have a plus here, but there's nothing to factor. So what's my LCD? Well, the LCD of x and x minus 1 is both of them. X is the monomial, and x, sorry, it's the plus 1. I might have said minus 1. X plus 1. Okay? You need both denominators. Just multiply them. Sometimes all you can do is multiply the 2 to find your LCD. All right? Now I'm going to distribute the entire LCD. I'm going to write it one more time. Distribute entire LCD to all the terms on both sides, including, and very importantly, the 1 on the other side. So I'm going to write x x plus 1, x plus 1, x plus 1. Okay? And again, if you do this right, you won't end up with these fractions, right? Here I didn't end up with any fractions, right? So here x's cancel and you get 4 parenthesis x plus 1. Then x plus 1's cancel, so I'm left with minus 3x. Now on the other side, what do you get? Well, now I have to distribute x squared plus x. All right, well, ooh, we have a quadratic. All right, so this one's quadratic. What do you do? Well, eventually I'm going to set it equal to 0 and factor. So let us distribute. And then we'll combine like terms. I've got 4x minus 3x. That's x plus 4 equals x squared plus x. Ooh, what happens to our x's? I subtract x and they cancel. Aha, so this is a super short quadratic. You do not need to factor it, though I could set it equal to 0 and factor it. But the faster way to do this one is by the opposite of squaring, the square root method. So x is the square root of 4, which is 2, and negative 2. 2 solutions for a quadratic, typically. 2 and negative 2. All right. Are they both good? Well, let us check versus restrictions. What can x not equal? Well, x can't be 0 from x, and from x plus 1, negative 1. So I did not get the restrictions. 2 good answers. All right. Solving rational equations. Now we'll move on to the SPs, the story problems. We'll do 3. Okay. So take your time on these. Read them carefully. Maybe you read them twice. There can be a lot to think about. All right, this first one says, the Young Republicans are creating flyers to be posted for an upcoming election. Matt and Jim are the only 2 volunteers to do the job. A total of 4,000 flyers must be made. Working together, they can complete the job in 6 hours. It's important, so 6 hours together. Matt can make flyers 3 times as fast as Jim. How long would it take each of them working alone? And if they worked alone. All right, let's see. I've got who? I've got Matt. And how long? We're looking for time. If he's alone. Then we've got Jim's time if he's alone. And together time. What am I given? I have to be given something. We are given together time, 6 hours. Okay, for one job, which is 4,000 flyers. All right. Now, am I given Matt's time or Jim's time? No. All right, so what else am I given? Well, I'm told Matt can make flyers 3 times as fast as Jim. So Matt is faster. Okay? Matt's faster. Okay? Jim is slower. Okay? So the faster one, Matt, is going to take T amount of time. And the slower one, Jim, is going to take 3 times as long. And that's just for one job each, right? All right. Now you could put 4,000 for all of these, but if they're all the same, 4,000, 4,000, 4,000, you can just put 1 as one job, okay? All right, so this is my information. Now we're gonna set up the problem. We're gonna do Matt's work over time plus Jim's work over time equals the together work over time. Okay, your variables will be in the denominator, right? So we've got the work over time alone plus the work over time alone will equal the work over time together. That's how we're setting these up. These are the alones. Okay, now I definitely need an LCD of t, 3t, and 6. The LCD is 6t. And I'm going to distribute that 1, 2, 3 times and get rid of all 3 fractions. First, the t's cancel. You get 6 plus. T's cancel. 1 times 6 divided by 3, 2 equals. 6's cancel. 1 times 2t. Well, that was fast. T equals 8. 8 what? 8 hours for whom? For the faster guy, Matt. Alone. 1 job. That's 4,000 flyers. All right. Now, Jim is 3t, so 3 times 8. 24 hours for Jim alone. 4,000 flyers. 3 times as long. But if they were together, they can get the whole thing done in 6 hours. That's the power of working together. Okay. Number 2, little different problem. We have the sum of the reciprocals. 3 integers is 7 over 24. Okay. The second number is 1.5 times the first. The third number is 10 more than the first. Find the integers. How many integers are there? Hopefully you said 3. All right. Always let the first be x. Okay. Second is 1.5 times x. 1.5 is, I'm going to change that to improper, 3 halves. Okay. Now what's the third? Third is 10 more than the first. 10 more than means x plus 10. Okay, so I have my 3 numbers, all right? And they're integers, meaning they're not going to be fractions or decimals. Okay? Get a nice answer like 8 or something. Okay, now we set up the equation. We need to sum up the reciprocals. Okay, so what's the reciprocal of x? That is 1 over x, right? Because you have x over 1, and you flip it. Okay. What's the reciprocal of 3 halves x? Well, that's 1 over 3 halves x. Plus the reciprocal of x plus 10 is 1 over x plus 10. And that all equals a fraction, of course, 7 over 24. All right. Now, I am going to find an LCD. But first, I have what's known as a little complex fraction. I do not want that 2. I don't want this fraction within the fraction. So right here, I'm going to get rid of that by multiplying the top and the bottom, the numerator and the denominator by 2. Okay. So that all I'm going to do is change this second fraction so that it doesn't have a fraction within a fraction. So up top now I have a 2, and then the denominator I have a 3x. Okay. Basically, just do the reciprocal of 3 halves, which is 2/3. All right. Now let's find the LCD. Okay. X, 3x, and 24 of the monomial parts. All right. What's the LCD? X, 3x, and 24 is 24x. 3 is the factor of 24, so you go with the bigger number, and then you need x. And then, of course, you need the binomial x plus 10. So here's our LCD. I'm going to write it now 1, 2, 3, 4 times, and cancel, 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 cancel. So we get rid of all the fractions. So we have 24x, x plus 10 times 1. Then 24x, x plus 10. 24x, x plus 10. And lastly, 24x, x plus 10. All right, you're distributing the entire LCD. And we're going to get rid of all 4 fractions. First, by canceling the x's, cancel. And I've got 24, x plus 10. All right, then what cancels? Well, x's. And what's 24 divided by 3? That's 8. So now I've got 8 times 2. I got to distribute 16 to x plus 10. Then what about this third fraction? X plus 10's cancel, and I get 1 times 24x, 24x equals. Finally, on the other side, 24's cancel. Now don't forget you still have that x. So you have 7x, 7 times x plus 10. All right, now this is a long one. I got to do a lot of distributing and combining like terms. So 24x plus 240, and then 16x plus 160, then 24x's, then distribute again, 7x squared plus 70x's. All right, now what? Let's combine how many x's? 24, 16, and 24, that's 48 and 16, 64x's plus 240 and 160, 400 equals 7x squared plus 70x. All right. Quite a bit more complicated than the first one. This is quadratic. We're going to set it equal to, hopefully, you said 0. All right. And we're going to factor 7x squared. Plus how many x's? Looks like only 6 minus 400. Oof. This is kind of a long one to factor. All right, you could, if you really wanted to, use the quadratic formula, but it's going to factor because the answer is an integer. So let's see. 7 is 7 and 1. All right. Now what about negative 400? This has a lot of factors. All right. If I started out with the 2 closest, I'd have 20 and negative 20. Okay. But that would give me something way too negative or way too positive. I need 6. So that's not going to work. What else could I try? There's a lot of options. This one might be one to try the calculator with. But when I think of 400, really even just 40, I think of 8 and 5. 8 times 5 to get 40. So what about maybe 8 and 50? Which one's negative? Let's see. Look what I could do. I can get 56 and negative 50. That adds up to 6. So the 50 is negative, 8's positive, 7 and 1. So what do we get? We get 7x minus 50 and x plus 8. 2 solutions, maybe. 57s and negative 8. But are they both integers? Are they integers? No. An integer is not a fraction, so I do get one answer. 57ths is extraneous. Okay. All right, so what are the 3 integers? Well, we have negative 8. Then what's 3 halves times negative 8? Well, that's negative 12. Then finally, what's negative 8 plus 10? Positive 2. Here are the 3 integers. Negative 8, negative 12, positive 2. Ooh, that's a long one. Okay, final problem. Back to a problem like number 1. It says Dan can paint 1/3 of a shed in his neighbor's yard in 4 hours. Let me just put this down. Dan, 4 hours, 1/3. Okay. If he works together with the neighbor, he can paint the shed in 4.5 hours. Let's see, I'll put together last. Together, it'd be 4.5 for the shed, which is 1. How long will it take his neighbor to paint the shed if he works alone? So there's the variable. Neighbor time. T. Alone for the shed, 1 shed. Okay. Here's my setup. So instead of just 1 on 1 for the work, we've got 1/3, 1, 1. Okay. All right, so we do alone work. So Dan's alone work is 1/3 over his time, 4 hours, plus alone neighbor, 1 over time, T, we don't know, equals the together 1 over now 4.5. I'm going to write that as a complex improper. That's 9/2. Okay. Then I have these 2 little complex fractions. We're going to do those separately. Okay. I look at the 3. I want to get rid of it. I'm going to multiply by 3 and by 3. And the 3's cancel. I get 1 over 12 plus 1 over t equals. Now here I multiply by this denominator, which is 2. Right, so up top I get 1 times 2, 2 over 9. Right, so that I don't have complex fractions. Okay, so this, we just changed this. Dan can do 1/3 the shed in 4 hours. Right? So then if I times by 3, it says, oh yeah, he can do a whole shed in 12 hours. All right. Now, what's the LCD? What's the LCD of 12, T, and 9? LCD. I don't think we have to go super high and multiply 12 times 9. I think we just need to go up to 36. And we need T. All right, so my LCD is 36T, 36T, and 36T. And we're going to get rid of all the fractions. 36t divided by 12, I've got 3t, plus t's cancel, 36 equals 36 divided by 4, or 8, that gives 9, sorry, that gives me 4, times 2, I got 8t. And of course you can use a calculator. All right, subtract 3t, 36 is 5t, divide. T is 36/5, which is 7 and what? Just 1/5 left over. Hours. That's for the neighbor. If he works alone. Paint 1 shed. One-fifth of an hour, that's 0.2. If you want to be real specific, that'd be 7 hours. 0.2 times 60, 12 minutes. Or go over help amount. And you got 4.5 hours. Okay. All right, so these are rational equations and story problems. You'll have a couple of review sheets to work on. Practice makes perfect with these things.